Hi everyone, so we're going to look at some examples of velocity time graph questions. So here's our first example. A body starts from rest, accelerates uniformly, so this one's going to have positive acceleration, positive gradient, and if you remember, acceleration is the gradient of your velocity time graph, whereas distance travelled is the area underneath your velocity time graph. Okay, so a body starts from rest, accelerates uniformly, tells us it accelerates to 8 meters per second in 2 seconds, maintains that velocity for a further 5 seconds, and then decelerates uniformly to rest, and the entire journey takes 11 seconds, so there's our total time. So let's draw a velocity time graph. Sometimes they'll give us the graph, quite often they'll ask us to draw it. So let's have a look at drawing this. So time on the x-axis, velocity on the y-axis. So starts from rest, so from rest, I've talked about that before, from rest, that means my initial velocity is 0, so I'm starting here. Accelerates uniformly, so uniform acceleration, constant acceleration, the gradient's going to be a straight line here to a velocity of 8 meters per second, and that takes 2 seconds. So there's our first part of our journey on our velocity time graph. And we're going to do some questions in a second. I'm just going to work out the acceleration once we've drawn the diagram. Okay. Then it says it maintains this velocity for a further 5 seconds. 1, 2, 3, 4, 5. You don't need to draw this to scale. So for a further 5 seconds, it stays at that velocity of 8 meters per second. And in this section, our acceleration is 0 because the gradient here, the line's horizontal, velocity is constant, so our acceleration here, our gradient here is 0. There's no change in the velocity. And then, maintains that for a further 5 seconds, then decelerates uniformly to rest. So again, decelerates negative acceleration, so negative gradient, uniformly to rest, so it's going to come down to velocity equals 0, and it tells us the entire journey takes 11 seconds. So 7, 8, 9, 10, 11. So we're decelerating in this third part of the journey. And quite often you get these sort of 3-part journeys: acceleration, constant acceleration, deceleration. Sorry, constant velocity, which is acceleration 0. So positive acceleration, acceleration 0, negative acceleration. So there's our velocity time graph drawn. So now let's have a look at answering these questions. So first of all, the acceleration for the initial part of the motion, so that's this part of the motion, acceleration, we've put in our notes, is the gradient of our velocity time graph. So change in y is 8 over change in x is 2. Velocity, change in velocity over change in time. So that's going to give me 4 meters per second squared for my acceleration. And we could here have used our Suvat equation. So we could have used v equals u plus at. And then v is equal to 8, u is equal to 0, a we're trying to find, and t is equal to 2. But you get exactly the same thing. And because we've drawn the graph, we might as well just do it from the gradient of the graph. Okay. The second bit then is the deceleration. So let's have a look at the deceleration. Okay. Well, let's just think about the acceleration first of all. So the acceleration is equal to the gradient. So here, we've got to be careful here. Look, it's got negative gradient going down. So my change in y is negative 8 because I'm going from 8 to 0. So minus 8 there. We could just put a negative in front of the whole thing. And the change in time there is 4 seconds. So minus 2 meters per second squared. So that's our acceleration. So that's a deceleration of 2 meters per second squared. Okay, so negative acceleration means it's deceleration, but we've got to make sure we're getting that negative involved there because it's negative gradient. And again, you could have used Suvat, same sort of thing here, and got the right answer from doing that. Okay. Part C. The total distance travelled. So it wants the whole distance of this journey, and the total distance travelled, again, we've just put this in our notes, that's going to be my total area under my velocity time graph. just going to move my paper up a little bit. So this is going to be a trapezium, area of trapezium, a half, the sum of the parallel sides, 11 for that side, 5 for that side, half a plus b times the perpendicular height, which is 8 in this question. So that's going to give me 4 times 16, that's going to give me 64 metres. So that's that question done. And again here, just like here, we could have used SUVAT. We could have used SUVAT here, but if we're going to use SUVAT, we've got to be really careful. We've got to do 3 separate parts of the motion because the acceleration is different in these 3 parts of the motion. But let me just convince you that that would work. So let's have a look at using SUVAT. Let's use S equals U plus V T over 2. Don't have to use that. Could use other equations as well, but let's just look at this. So for the first part of the motion, for this first bit, so let's call that 1. This first bit, we're going to have my displacement there for this journey is going to be U is 0, V is 8, over 2, the time taken is 2 as well, so that's going to give me 8 metres. For the second part of the journey here, the second part of the journey, the initial velocity and the final velocity are both 8. And then the time taken there is 5. 16 over 2, 8 times 5, that's going to give me 40 metres. And then for the third and final part of the journey, so for here, initial velocity is 8, final velocity is 0, over 2, time taken is 4, so that's going to give me 4 times 4 is 16. If I add those displacements together, first part of the journey, middle section of the journey, last part of the journey, I'm going to get 64 metres, so that does definitely work. Okay, so this 3-part motion where we've got positive acceleration, in this case it was 4, 0 acceleration, so constant velocity, and then deceleration, so my negative acceleration there, and that's quite common in questions. So that's our first sort of introductory example. I'm going to stop the video. I'd like you to get that into your notes, and I'm going to do a couple more examples of this today.